When we convert, we have to make sure the quantity stays the same. If I lend you $1 and the next day you pay me back with 90 cents, then I'll say, hey, hang on a second, that's not the same. What's wrong with what happened? Well, you took my $1 and you multiplied it by less than 1. And that's wrong. When we convert, we have to make sure we keep the amount, $1, the same. How do we keep the amount the same? Instead of multiplying by 0.9 or anything else, we always multiply by 1. So whenever you convert, for example, if we have 2 kilometers and we say, well, 1 kilometer is equal to 1,000 meters, this fraction that we multiply by equals 1. That's really important, because if it didn't equal 1, then we would not be preserving the original quantity. So here's how we can think about converting from one unit to another. First, we need to know what is equal to what. Let's say, for example, we're given that giga, a unit prefix, equals 10 to the positive 9. If I'm provided with some quantity, maybe it's 4.5 gigajoules, when I multiply, I have to make sure the fraction equals 1. So pretend for the moment that we're trying to convert from gigajoules into some number of joules. So there was a giga, and we want the giga to go away. We have to cancel it out. When you convert, if you're canceling giga out, we put it on bottom, and now we'll have giga over giga, which is equal to 1, and so it goes away. So what do we have to put on top? Don't forget, to make the fraction equal to 1, the numerator and denominator must be equal. So if you put giga on bottom, then the numerator must be equal to a giga, and 10 to the 9 is the correct power. So now when we multiply, we'll be having the giga canceling out, and in effect we'll have 4.5 times 10 to the 9 times joules. The joule, the unit, is almost like a factor we multiply by. And so when we finish our answer and finally calculate, the answer will simply be 4.9 times 10 to the 9 joules. That's our final answer. What if we have a different scenario? For example, imagine that we have 5.6 micrograms, and we need to convert into, let's say actually we have 5.6 grams, and we need to convert into micrograms. This is the Greek letter mu, by the way. To make this conversion, we need to know what micro equals. Micro is 10 to the minus 6. Okay, so write down the original amount, 5.6 grams, and make sure we don't change that amount. How do we guarantee that this stays the same? Multiply by 1. So I'm going to multiply by a fraction that equals 1. Where does the micro go? On the top or on the bottom? Which one is correct? Well, we want micro to be right there beside grams. Micro has to be in the numerator. So let's add it. And then the corresponding power of 10 always goes on the other side of the fraction. That's how we guarantee that the numerator and denominator are equal. When we multiply by this fraction, we are multiplying by 1, so we preserve this original quantity. And when you work this out, you'll have 5.6 times mu times 1 over 10 to the minus 6 times grams. So you simply combine these values, and that will come to 5.6 times 10 to the 6. And then after you combine the values, you combine the units and put micro, the prefix, before grams, the unit. Grams is the unit, and this micro is called the prefix or the multiplier. That's how we convert.